everyone, this is Sahiti on behalf of EduReka, and I welcome you to this session on data analytics for beginners. So this session will help you understand how you can start with data analytics. So before I begin with the session, let me just quickly cover the concepts that we're going to cover in today's session. So we'll start today's session by understanding the introduction to data analytics, and then I'll tell you what is statistics. After that, I'll tell you how you can perform data cleaning and data manipulation and also data visualization. Once you understand the basic skills, that is the statistics, data cleaning, data visualization, I'll tell you the plus point of a data analyst, that is a machine learning. So I'll just talk about machine learning a little bit and then I'll tell you the roles and responsibilities and salary of a data analyst. Once you understand all the theory part of this session, I'll end this session with a hands-on part where we'll see how you can perform data analytics on a specific data set, right? So I hope that the agenda is clear to you guys. So now, as I said, the first topic is the introduction to data analytics. Let me just quickly cover why do we need data analytics. So with the presence of humongous data around us, it's obvious that we need to analyze the data for our benefits, either for gathering the hidden insights or for generating reports. Data analytics benefits the enterprises by performing proper market analysis and improving the business requirements. So in today's market, this field has gained a lot of popularity in terms of number, because it lets you gather hidden insights, generate reports, perform market analysis, and also improve business requirements. So with the note of this, let me tell you what exactly is data analytics. So as the word data analytics suggests, data analytics refers to the techniques to analyze the data to enhance the productivity and business gain. Data is extracted from various sources and is categorized to analyze different behavior patterns. Now, the techniques and the tools used to perform data analytics vary from organization to organization, or you can say individual to individual, right? So if I have to define data analytics for you, then data analytics is the process of inspecting, cleaning, transforming and modeling the data with the goal of discovering useful information, suggesting conclusions and supporting decision making. So in short, if you have an understanding of your business administration and also have the capability to perform exploratory data analysis to gather the required information, then you're good to start the career in the data analytics field. So talking about career in data analytics, once you understand and you have the capability of performing business administration with exploratory data analysis, you would become a data analyst. So now let me just quickly tell you who exactly is a data analyst. So a data analyst is a professional who collects the data from various sources and analyzes the data on various aspects and then finally generates the reports. Now, these reports are distributed to the respective teams to use the analyzed data and provide improvement in the business. So if you have to become a data analyst, then you need a set of skills as you can see on the screen. So the basic skills that data analysts should possess are the ability to perform statistics, data cleaning, and also have the capability to perform exploratory data analysis and data visualization. Apart from these skills, if a data analyst also has a knowledge of machine learning, then that would obviously add a bonus point to his or her skill set, as he or she would be able to build a model and then test the model also, right? So don't worry guys, I'll be talking about each of the skills one by one. Starting with statistics. Statistics is a mathematical science pertaining to data collection, analysis, interpretation, and presentation. It is used to process complex problems in real world so that the analyst can look for meaningful trends and changes. Analysts review the data so that they can reach conclusions, and several statistic functions, principles, and algorithms are implemented to analyze the raw data, build a statistical model, and infer or predict the result. So if you just have to understand statistics in a single sentence, then statistics is a branch of mathematics dealing with the data collection and organization and then performing analysis, interpretation, and presentation, right? So statistical analysis has basically two categories, the descriptive statistics and the inferential statistics. So let's get started by understanding each one of them one by one. So starting with descriptive statistics uses the data to provide descriptions of population either through numerical calculations or graphs or tables. So now descriptive statistics helps organize data and focuses on characteristics of data, providing the parameters. So as you can see the example on the screen, suppose you want to distinguish the objects based on the color, then you can see that this type of statistics, that is basically the descriptive statistics, divides the data into two sections based on the colors. So that's black and red over here. Now, if I have to make it more generalized for you, then suppose you want to study the average height of students in a classroom. In descriptive statistics, what you would do is you would record the heights of all the students in the class, and then you would find out the maximum, minimum, and the average height of the class, right? Now, this was just a simple example, guys. If you look into the enterprise level, then you may have a large data set, with various number of columns, right? Now, you can just pick up one column and then you can find the minimum, maximum, and the average of that particular column, right? Also, in descriptive statistics, we try to represent the data in the form of graphs like histogram, line plots, scatter plots, and so on. But yes, the data is represented based on some kind of central tendency. Now, when I say central tendency, I mean that a particular graph represents the distribution of mean or the measure of spread, or depends on what kind of a graph you're using or what's on your graph, right? So for that, you have to understand few measures in statistics. So those are basically the measures of center and the measures of spread. So talking about the measures of center, there are mainly three terms that you need to understand, which are the mean, median, and the mode. So starting with the mean is basically the measure of average of all the values in the sample. So suppose, if you consider the example in the screen, then if you want to calculate the mean of the sample that is present on the screen, you just have to add all the numbers and divide it by the number of numbers, right? So since we want to find the mean of 8 values, we're going to divide the complete sum by 8. And that's how you can calculate the mean of the sample. Alright, moving on to the next term, that is median. Median is basically the measure of central value of the sample set. So if you consider the example on the screen, then you can see that there are 8 values, right? Now to calculate the median, you have to consider the fourth value and the fifth value and then divide it by 2. So since our fourth value over here is 22.8 and the fifth value is 23, I'm just going to add both these values and divide it by 2. So the value that you get, that is 22.9, is the median of the sample, right? Now moving on to the next term, that is mode. Mode is nothing but the value most recurrent in the sample set. So if you consider the example on the screen, then out of all the numbers that you see on your left hand side, you would see that 25 occurs the maximum number of times, right? So 25 would be the mode for this particular sample set. So as and when the sample set changes, the mean, median, mode values also change, right? So those were the measure of center, guys. Now moving on to the next measure, that is the measure of spread. The measure of spread again has basically four terms that you need to understand. That is the range, interquartile range, variance, and the standard deviation. Starting with the range. Range is basically the given measure of how spread apart the values are in a data set, right? So suppose you have 10 values. Then if you want to calculate the range of these 10 values, you just have to subtract the minimum value from the maximum value, right? So that's what the formula is, guys. That is maximum minus minimum. Now moving on to the next term, that is the interquartile range. Interquartile range is basically the measure of variability based on dividing the data sets into quartiles. Now to understand quartiles, let me just consider a sample set of 8 values, right? So let me just quickly open my notepad and show you how you can calculate the interquartile range. So let's say, we have 8 values, 1, 2, 3, 4, 5, 6, 7, 8. Now to calculate the interquartile range, what you simply have to do is first you have to calculate the quartiles, right? Now to calculate the quartiles, you have to find the average between two numbers. So when I say two numbers, you have to calculate the average between 2 and 3. Then you have to calculate the average between 4 and 5. And then you have to calculate the average between 6 and 7, right? So let me just quickly calculate the average. So what I'll do is I'll just add these two terms and then I'll divide it by 2, right? So this would be equal to 2.5. So that's 2 plus 3 by 2. That's 5 by 2 is 2.5. Similarly, I would calculate 4 plus 5. That is 9. 9 by 2 is 4.5. So I'm just going to put 4.5 over here. So let me just write that. And then finally, let's just add 6 plus 7. That is 13 by 2. That is again 6.5, right? So basically, you have three values, that is 2.5, 4.5, and 6.5. So basically, these values would define your quartiles. So the first quartile would be after 2, the second quartile would be after 4, and the third quartile would be after 6, right? So what will happen is your sample set would be divided like this, right? So as you can see on the screen, we have 4 quartiles. Now the difference between the first quartile and the third quartile would be your interquartile range. So if you just want to calculate interquartile range, what you simply have to do is you have to first calculate the quartiles for your sample set, and then the difference between two quartiles would be your interquartile range, right? So I hope I'm clear with this part. Now moving on to the next term, that is variance. Variance basically describes how much a random value differs from its expected value, right? So basically, whenever you want to calculate how much any random value differs from its expected value, then you're basically calculating variance. It basically entails the computing squares of deviations. Now, with that, let's move on to the final term, that is the standard deviation. So standard deviation is basically the measure of dispersion of set of data from its mean, right? So whenever you calculate the mean, and then whenever you want to calculate how far is the dispersion of set of data from its mean, you would basically calculate standard deviation. So folks, I'm not going to go into depth of how you have to calculate each of these terms. If you want to learn more about statistics, I'll leave a video's link in the description box, and you can refer to that video, that is basically statistics for data science, where you'll understand all these terms based on statistics, and you'll understand how you can calculate the values, right? So guys, that was all about various measures that you need to go through in descriptive statistics. Now moving on to the inferential statistics, that is the second category in the statistics. This is basically used to build a model and then give a probable solution. So inferential statistics basically generalizes a large data set and applies a probability to draw a conclusion. It allows us to infer data parameters based on statistical model using a simple data set. So again, let's just take the same example of, we have to segregate few objects based on the color. Now, when you implement inferential statistics on these same objects, what would happen is a statistical model will be built, and based on that, a conclusion would be given, right? So that's how inferential statistics is. If you have to understand, if I have to generalize this for you, then you can again take the example of calculating average height of students in a classroom. Over here, what would happen is we would take a sample set of the class, and then if we want to apply inferential statistics, what we would do is we would group the students into tall, average, and short heights, and then based on this, we would build a statistical model and expand it for the entire population, right? So guys, that was all about descriptive statistics and the inferential statistics. Now, inferential statistics has one more term, that is hypothesis testing, that you need to understand. So hypothesis testing is an inferential technique to determine whether there is enough evidence in a data sample to infer whether a certain condition holds true for an entire population or not. So what basically happens is, under the characteristics of general population, we take a random sample and analyze the properties of the sample. We test whether or not the identified conclusion represents the population accurately, and finally we interpret their results, right? So whether or not to accept the hypothesis completely depends on the percentage value we get from the hypothesis. So hypothesis testing is basically conducted in the following manner that you can see on the screen. It starts with the state of hypothesis, and this stage basically involves stating the null and the alternative hypothesis. Then we basically formulate an analysis plan, where the stage involves the construction of the analysis plan, and then we move on to analyzing the sample data. So in this stage, it basically involves the calculation and interpretation of the test statistics as described in the analysis plan that we formulate before. And then we finally interpret the results, where this involves basically the application of decision rule described in the analysis plan, right? So guys, that's how you conduct the hypothesis testing. So guys, that was all about inferential statistics. So now let me just quickly brush you over the differences between descriptive statistics and inferential statistics. So descriptive statistics is basically concerned with the properties of population, whereas inferential makes inferences from the sample. Descriptive presents the data in a meaningful manner, whereas inferential compares and predicts the future outcomes. Descriptive statistics outcomes are shown in the form of charts, tables, and graphs, and inferential statistics outcomes are basically shown in the form of probability scores. In descriptive statistics, it basically describes the known data, but in inferential statistics, it tries to make the conclusions beyond the data that's available. And finally, coming to the last difference, descriptive statistics has the measures of central tendency and spread of data, whereas inferential has hypothesis testing and analysis of variance, which is basically the ANOVA model, right? So I hope guys, the differences between the descriptive and the inferential statistics are clear to you guys. So now let me just quickly move on to the next skill that is important for a data analyst, that is basically data cleaning and data manipulation. Now, once you get your data, the first step would be to remove all the unwanted data. So the process of detecting and correcting corrupt or inaccurate records from a database is basically said to be data cleaning or data cleansing or data wrangling. So you need to make sure that all the null values, the corrupted values, or a column from the data are removed before you start analyzing the data. And once you remove such values from the data, the next step to perform is basically data manipulation, which is nothing but exploratory data analysis. So if I have to just define data manipulation for you, then it's the process of changing data to make it more organized and easier to read. and this is nothing but data manipulation. So whenever you make your data in a more organized manner, you make all the tuples clear, and then you have all the column values in a clear manner, and it's easy to read and analyze. It's basically known as data manipulation. It's not required that if you have 5,000 tuples, you view all the 5,000 tuples together. You can use some functions to just view the top 10 tuples or the bottom 10 tuples, so that you understand what are the various parameters or what are the columns that are present in the data set, right? So in this particular step, what you can do is you can completely reorganize the data into various forms based on whatever column names that you wish, or you can just add few columns or delete few columns, you can remove few tuples, or you can just merge few columns, and so on. So don't worry folks, I'll be showing you a demo where you will be performing data manipulation. Now moving on to the next skill for a data analyst, that is basically data visualization. So data visualization is nothing but the representation of data in forms of charts, diagrams, etc. Right? So you can represent your data either in the form of bar graphs, scatter plots, pie charts, box plots, line graphs, and so on. Not only this, but you can also visualize the data in form of complex plots like histograms, and use 2 to 3 different plots together. Like you can have a scatter plot which has a line graph, or you can have two different plots of histograms, and then you can have a line graph over it, and so on, right? So it's completely based on your understanding of what kind of a plot that you want, or it's completely based on how you want to see your data or how you want to visualize your data, right? So guys, these were the basic skills that a data analyst must have. We started with statistics, and then I told you the various categories of statistics and how you can calculate the various measures in both of them. After that, I told you about data cleaning and data manipulation, which is nothing but the exploratory data analysis, where you clean your data, remove all the null values or the corrupted values, and then you can reorganize your data, reorganize your columns. And finally, we moved on to data visualization, where the columns between which you want to visualize the data, right? So these were some basic skills that every data analyst should have. But yes, if you have an understanding of machine learning, then that would be obviously a plus point to your skills, right? So now let me just quickly tell you what machine learning is in short, so that you understand what machine learning is, and then we'll quickly shift to the demo part. So well, machine learning is basically a concept which allows the machine to learn from examples and experience, and that too without being explicitly programmed. So what basically happens is whatever data that you pass to the machine learning algorithm, the algorithm learns from the data, and then it predicts the output for you. So as you can see on the screen, we have a training data, and then the data is passed on to the machine learning algorithm. After that, the model is created. Now over here, even if we add a new input data, then that would pass to the machine learning algorithm which was created, and a prediction would be given as an output. Now once the prediction is given, you can just check whether it's a successful model or not based on the requirement that you have, right? So that's about ML, guys. If you want to learn in depth about ML, I'll leave a video in the description box, and you can understand from there what exactly ML is and where is it used, how is it used, what companies are using it, and so on. So guys, these were all the skills for a data analyst. As I'm talking so much about data analyst, let me just quickly tell you the roles and responsibilities of a data analyst. He or she should be able to determine organization goals. He or she should have the capability to mine the data, that is basically performing data mining, and also perform data cleaning. Once data is being cleaned, he or she should be able to analyze the data properly and pinpoint the trends and patterns, or you can say the behavioral patterns, and finally create reports with visualizations, right? So basically, if you become a data analyst, these are the various roles and responsibilities that you would be responsible for. You should be able to determine the organization goals, you should be able to mine data, you should be able to perform data cleaning or wrangling, you should be also able to analyze data and pinpoint the trends and patterns in the particular data, and finally create the reports with visualization, right? So I hope that the roles and responsibilities are also clear to you. Now, looking at so much of roles and responsibilities, you might be wondering, right, what could be the salary of a data analyst? Well, the average salary for a data analyst in US is around $83,000, and in India is around 4 lakhs, right? So guys, these are the starting salaries. But as and when you have a good expertise of data analysis and you're able to perform machine learning algorithms, you would be great in the market and you would have a great market value, right? This was all about the skills, roles, responsibilities about a data analyst. Now let me just quickly move on to the need of R, because the hands-on that I'm going to show you is based on R. So basically, R is again a programming language that is basically used for data analytics. So R is basically open source and it's freely available. It is cross-platform compatible. So, you can have R with Power BI. So as you know, Power BI is a visualization tool. You can create reports using both of these tools together. R is also a powerful scripting language. It is highly flexible and is evolved. And let me tell you, it's really simple to code in R because you just have to install few packages, and then you just have to understand how these packages have various functions to take care of your needs, right? So guys, this was all about the theory part of the session. I hope that you've understood what exactly data analytics is. Now let me just quickly move on to the demo part. So what I've done is I've basically chosen a data set which has various columns like the person weight, the person height, body mass index, pulse rate, and so on. So let me just quickly open the data set and show you what exactly the data set is about. So as you can see on the screen, this is basically the data set that I've chosen. I have a person ID, the gender, the person age, race, education, marital status, the relationship status, and then insurance, salary, poverty, number of house owned, if it's rented, the rooms, the person body index, pulse rate, and then various other health parameters, right? So we're going to basically perform analysis on this particular data. What we're going to do is we're going to first import the data set into R, and then we'll perform descriptive statistics on it that I was talking about in the theory part. After that, we're going to deal with the missing data, and then we'll perform data visualization. So we'll basically perform data visualization between two columns so that you understand how the values in the two columns vary with each other. And then we'll move on to inferential statistics. So, where I'll perform t-test for you guys. After that, I'm going to just apply a machine learning algorithm that is perform linear regression so that you understand how that's a plus point for a data analyst, right? So I hope that, the process is really clear to you guys. So let me just open my RStudio and quickly show you the code. All right. So as you can see on the screen, this is the code that I've previously written. So I'm just going to show you guys by running each of these commands one by one. So the first step that I mentioned is to import the data set, right? Now before that, let me tell you that, we're going to use the dplyr package for this complete code. So the dplyr package basically offers various functions by which, we're going to perform various functions on our data set. So you can just install this package if you don't have it installed on your RStudio. But yes, if you do have it installed, you just have to use the library, right? So I've already installed in my RStudio, so I'm not going to do that again. Now what I'll do is I'll just import the dataset directly. So to import the dataset, you have to mention the read.csv file. That's because my sample dataset is in the form of a CSV file. Or if you had any other types of file, then you have to mention accordingly. Okay. So if you just type in read, you can see various options for various kinds of files. So since I have a CSV file, I'm just going to type in CSV, right? And then what I've done is I've mentioned the directory of the file, right? So since my file is present on desktop, I've just mentioned the directory, and then I can just execute this particular command. But yes, let me tell you, once the file is read, what I've done is I've just assigned it to a variable example over here. That will basically make it easy for me to use this variable again and again to perform various steps in the analyzing part. I've just assigned this complete file to an example variable. Now let me just run this particular command. So what I'm going to do is I'm going to just press on Control Enter. So that's basically a keyboard shortcut to run this particular line. If you just want to run the complete R script that you've written, then you can just press on Control Shift Enter, right? So I'm just going to press on Control Enter, and you can see that this particular command has got executed. Now if you just want to view the dataset, what you can simply do is you can just use the command view example, and then you can click on run, and you can see that your complete dataset, that is basically your sample dataset which was present over here, has got imported into the RStudio where you can perform various analysis functions, right? So you can see all the columns and all the values have come over here, right? Now if you observe this particular data set, you have 5,000 entries, right? Now it cannot happen that you observe 5,000 entries in your console, right? So to just observe the top 10 entries, what you can simply do is you can use this function tbl-df, that is basically creating a data frame for your data set. So what I'll do is I'll just type in tbl-df, I'll mention this variable name, that is basically example over here, and then I'll again assign it back to example, right? So if I just run this particular command, you can see that this gets executed. And then if I just type in example, you will see that only 10 rows get printed. So let me just drag this up for you. You can see that we have 10 rows printed to check all the values, and we also have a table that is basically 5,000 into 32, which says that we have 32 columns and 5,000 entries, right? So that's how guys you can use this particular function to see the top 10 rows. Now what we're going to do is we're going to just use simple commands like head, tail, dimension, names, and glimpse to just look into the data set more clearly. So what the head function does is that it basically shows the first few rows. The tail, as the name suggests, shows the last few rows. The dimension shows the number of rows into number of columns. So just in case if you just want to look into the names of the columns, then you can just use names, and glimpse basically shows the structure of the data set. So I'm going to first run head so that you see few rows. So as you can see, it has printed 6 rows, and it has printed around 1, 2, 3, 4, 5, 6, 7, 8 columns, right? So it has printed 6 rows and 8 columns, and it has also mentioned that there are total around 32 columns. Now similarly, if I run tail, then you can see that the last few rows are printed. So these are few last rows of the data set that we have chosen. Now moving on to the next command, that is dimension. So as I mentioned, dimension will basically give you the number of rows into number of columns. So that is basically 5000 into 32. Now names would be basically giving us the column name. So I'll just run in names, and you can see the 32 column names that we have. This will basically help you understand what are the different column names and what are the different column names that you can use to find the relations between the values. So we have an ID, sex, age, race, education level, status, relationship status, insurance, and so on, right? So these are few steps, guys, that are not really important, but yes, these will help you understand the data set more if you're new to data analytics, because you have to start understanding if there are any null values, or what are the number of rows, or what are the columns. If you have larger number of rows, like if you have around 50,000 tuples, then you cannot use 50,000 tuples to run each function, right? So that would require a lot of memory. So for that, you can just use a sample data set, like you can just use 5,000 rows, and then you can use the built model for the 50,000 one, right? Now moving on to glimpse. Glimpse again just shows the structure of the data set, as I mentioned before. So let me just run that command and show you. So as you can see, it is printing out all the column names, and then it is printing out all the values. So you can see that person ID is an integer, sex is in factor and has male female values, age is again an integer, race is again in factor, poverty is again in decimal points, and so on, right? So you'll know the data type, you know what kind of values are present over there, and then you can also know and what are the columns which have different kind of values, right? If you observe over here, there are a lot of NA values, right? So we're going to deal with them soon, so don't worry. Now let me just minimize it again. All right. So now that you know the basic commands in R, you know how you can start for analyzing the data. Let's start with the second step, that is the descriptive statistics. So if you remember in the descriptive statistics part, I told you that there's measure of center which has mean, median, mode, and there is measure of spread which has interquartile range, and so on, right? So what I'm going to basically do is first I'm going to display all the race values, and then I'm going to display the unique values of race and the length, right? So to display all the race values, if you see over here in the column, we have different race. We have Asian, we have black, we have white, we have Mexican, and so on, right? Now to display all these race values, what you simply have to do is you have to use the variable for the dataset, that is example, and use the $sign with the name of the column, right? So over here it's example $race. I'll just run this particular command, and you can see the output that we have got all the race values. Now if you want to find out the unique values, what I'll simply do is I'll use the unique function, and then I'll mention example $race. Similarly, if we want to find out the unique values for any other particular column, we just have to mention that particular column's name. Over here I'll mention unique example race, and then I'll run, and you can see that we have Asian, black, white, Mexican, Hispanic, other, as various races present in the column, right? Now if you want to find out the length of all these unique values, you just have to use the length function outside the unique function, and then you have to run this particular query, and you can see that the length is basically 6. So basically what's happening is, instead of counting Asian, black, white, Mexican, Hispanic, and other on fingers, what you can simply do is you just have to use the length function to find out how many unique values are present in the race column, right? So that's how you can use the length function, guys. Now moving on to the next part, if you just want to calculate the mean, median, and range of any particular column, let's say age over here, what you simply have to do is you have to use the inbuilt functions in R, that is the mean, median, range, and then you have to mention the variable name, dollar, and the column name, right? So if you have to calculate the mean, what you'll simply do is you'll type in mean, and then you'll mention the variable name, that is example for the data set, mention dollar, that is to specifically access this particular column, that is to specifically access the column age, right? So I'll just run this particular command, and then you can see that 36 is basically the mean age. Similarly, you can calculate the median. Median is also 36, and the range is basically from 0 to 80. So that's how, guys, you can use descriptive statistics in R to find out the mean, median, and range. Now, if you just want to get a summary statistics on each variable in the data, you can just use the function summary, and then you have to mention the variable name, right? So I've mentioned summary example, and then if I run this particular command, you can clearly see that we've got summary of all the 32 columns that we have in our data set. So when I run this particular command, you can see that, for all the columns with the data type int, you get the minimum value, the first quadrant, the median, the mean, the third quadrant, and the maximum value. For the columns which have the data type factor, like for example, sex, we have number of females to be 2495 and number of males to be 2505. And similarly, when we see for race, we can see that, the Asians are at 288, the blacks are at 589, and so on, right? So that's how you can have an idea about, different values present for your data set. So you can get the number of values, the minimum, the medium, what are the various kind of values that are present in the column, and so on with this particular function, that is summary, right? So this is also one particular important feature that you need to analyze in any data set that you get to handle to. You have to understand what are the various factors, or what are the various types of values that are present in your columns, and what is the number of those values, right? So if I look into the employment status, you can clearly see that, the looking is 166, the not working is 1413, the working is at highest, that is 2263, and not applicable, that means it's null values, it is at 1158, right? So these are various features that you need to understand. Now that you've implemented descriptive statistics, let's move on to the third step, that is basically dealing with the missing data. So to deal with the missing data, first let me just calculate the mean of the salary, and then I'll explain you why we have to deal with the missing data. So when I calculate the mean of the salary, you'll see NA. Now, if I just open my data set and if I show you the salary column, you'll see that you have various columns which are not NA, right? But yes, you've got the output as NA, that means it's definitely wrong. You need to get the mean of the income. Now, since we have a lot of columns that could be NA in this particular column, that is the reason that we're getting the output as NA, right? So what we can simply do is we can just find out whether there are missing values or not. Here I had showed you because the missing value occurred at the 29th tuple itself, right? But just imagine you have 5,000 tuples and you don't know where is the NA value coming. You need a way to find out that, right? So that's by using the na.rm parameter. So na.rm basically indicates if whether there are missing values present or not. By default, this parameter is assigned to false, but yes, I'm mentioning it over to be true so that whether if we have any missing values, then this would return an output for us. So with this particular command, you can see that if the example dataset salary has any null values, that is basically true over here, then obviously we can calculate the number of null values present. So what you can do is, if you just run this particular command, you can see that the mean value is basically 57,000. Now apart from this, you can also use a is.na function, which basically tells you if your value is missing or not again. So what I'll simply do is I'll just mention this is.na function, and inside that I'll mention the data set $, the column name. Since I want to find it for salaries column, I'll just mention that particular column and I'll run this particular command. So this would basically return all the tuple values with either false or true. False means that there's no NA value over there, and true means that there's an NA value over there. So that's how you can find out if there is null value present in which row or which tuple, that you have to understand. Now if you want to just add all the number of null values to calculate how many null values are present in total, you can just use the sum function, that is basically the aggregate function in front of that is.na function, to calculate the number of null values. So that's basically, it would count the number of true values and then it would print for you. So you can see that we have 377 values which have null values in the column of salary, right? So now what I'm going to do is I'm going to just remove all these null values and then I'm going to replace them with the 0, right? So for that, what you simply have to do is you just have to use this function of is.na, mention the dataset name, and then assign a 0 to it and then assign it back to the dataset, right? So I've put a 0 and I've said if is.na example, that means if there's a true value in the example dataset, just replace it with a 0 and then assign it back to the same dataset, that is example, right? So I'll just run this particular command, and now let's just view the dataset again. So I'll just view the example again. Now you must have observed one thing over here, that is all the column with NA values did not get replaced with 0. Only the values which had the data type of int and they had NA values got replaced with 0. right? For the other factors like, your education level, marital status, relationship status, you can handle the null values based on various parameters. Like, you can just remove the tuples completely. You can just compare two factors and then mention the value. Suppose, if I just compare educational level and marital status, so I can see that, all the females belonging to the Mexican race can go to educational level of high school and our marital status are married, right? So I can just replace these values, any values like that. So it's completely based on you how you want to deal with the missing data set. Initially, I've just shown you how you can just remove the values and then how you can replace null values with something, right? So I just leave that part to you so that you explore how you can do that. Now moving on to the next part, that is basically the exploratory data analysis. Since we have analyzed the data and we have understood what are the various columns that can be analyzed, and what are the various columns that have null values and how some values got replaced with zero, what I'm simply going to do is I'm going to perform the next step, that is basically the data visualization, where I'm going to plot histograms for different column values, right? So what I'm going to do initially is I'm going to use this ggplot2 library. Just in case, if you do not have it installed in your RStudio, you can again just install this particular package by just using the command install.packages and then just mention the package name, and then you just have to load the library. Since I've already installed the package in my RStudio, I'm just going to run this particular command to just load the library, and then I'm going to perform data visualization, right? So if I just have to plot a histogram for you, what you can simply do is you can just use ggplot, and then you have to mention the dataset name, that is basically example as variable, and then you have to mention the parameter based on which you want to plot the data. So initially I want to plot the data for body mass index, and then I'll mention the bins to be 30, right? So I'll just run this particular command and then you can see the plot. So if I just zoom in this particular plot, you can see that in a body mass index at the count around from 20 to 40, like let's say, around 30 or, less than 30 is at the maximum, right? So with this, we can get the count of, what is the least value of body mass index, what is the maximum value of body mass index. That is basically the least count and the maximum count, right? Similarly, I can plot a histogram for a person weight. So I'll again just use the ggplot function. I'll mention the dataset variable and then I'll mention person weight, that is basically for which I want to visualize the histogram for. So let me just run this particular command and let me just zoom in this plot. So you can see that the person weight ranging from 50 to 100. Let's say this is around 75, that is less, but more than 75 to 100 is at the maximum value. So most people weigh around from 75 to 100, and very less people lay around from 50 to 200, and you can say none of them almost weigh around 200, right? Very few people weigh. So with such kind of visualizations, you can have a clear idea of how many people weigh more than, let's say, 100, or how many people weigh less than 100, or what is the maximum weight around the samples data set that is given to you, or what is the minimum count of a weight of the sample set that is given to you, and so on, right? So now what I've done is this person weight histogram was basically plotted on based on kgs, right? Now if I have to just convert into lbs, what I've just done is I've just multiplied it with 2.2, and then I've given a lot number of bins so that we get a clear visualization. So I've again used the ggplot function, and then I've mentioned the example data set, and after that in the A's column, I've mentioned person weight into 2.2 so that we want to convert the kgs to lbs, and then we've mentioned the number of bins. So I'll just run this particular command, and then what we'll do is we'll zoom in. So you can see that the weight around 150 to 200 lbs has the maximum number of count. If you just continuously keep zooming in and you keep increasing the bins, you'll see the outputs more clearly, right? So that was about this plot, guys. Now similarly, what I've done is I've again plotted a histogram for age to know whether there are kids present in the age distribution or not. So what I'll do is I'll just run this particular command again, where I've mentioned ggplot, that is basically the ggplot function, the again dataset name, the person age, that is basically the age column, and then I mentioned the bins. So when I zoom in, you can see that there are a lot of number of children that are present in the sample dataset whose age is less than 18. So this is one category that you can again use to visualize, or to analyze the dataset. You can just divide your dataset into children's dataset and then adults dataset and perform various actions. So that's how you can use this particular visualization for your benefit. Now, not only histogram, guys, so as I mentioned in the visualization part in the theory section, there are various number of plots like bar plot, scatter plot, line plot, box plot, and so on, right? So it's completely based on your understanding and your need, which kind of plot that you want to plot. Now suppose I want to compare the person's height with the person's weight, and then I also want the parameter of gender to be present. What I can do is I can just simply plot a scatter plot where I'll compare person's height to person's weight and then just color the scatter plot with the help of gender, right? So for that, you can again use the ggplot. You can mention example, that is basically the data set, and then I'll mention person height, person weight, and then color by sex, that is basically a gender, right? So when I run this particular command, you can see the output that we've got a plot of person's weight, person's height. So person's weight is compared with person's height, that is on the right hand side, that you can see that the pinkish red color represents female and the blue color represents the male. If person's height was around 100, then that would be maximum of male people present in this particular section. Let's say the person's height is around 150 and the weight is also around 100. We can see that there's a lot of female section present, right? So guys, that's how you can use data visualization to perform and understand various relationships between data. These were just few columns that I compared them, and these were just few columns or examples that I showed you. Well, you can play around with data as much as you want. So this is just one more trick, that whenever you create a visualization, just make a note of it. What are you getting out of it, right? So out of the visualization that you can see on the screen, what I'm basically getting is the person's weight to person's height comparison and how many female and male population is present in that particular scenario. So as you can see, the maximum population is present in this particular range, where the person's height ranges around 150 to 200 and the person's weight ranges around again, let's say 125 to 50, right? So that's how you can analyze data and gain some hidden insights. Now moving on to the next part, that is basically the inferential statistics. What I'm going to do is I'm going to perform t-test. So when I say t-test, t-tests are a type of hypothesis testing by which you can compare means. So each test that you perform on your sample data basically brings down your sample data to a single value, that is the t value. So as you can see on the screen, this is basically the formula of t value. So now what I'm going to do is I'm basically, going to filter the data set first. So to filter the data set, what I've just used is I've used the filter function. I've used the dataset name, that is basically example. And then you have to mention the parameter based on which you want to filter the data set. Now what I'm going to do is I'm going to just consider the adults. So I've just mentioned person's age to be greater than or equal to 18. After that, the complete data would be assigned to a different variable, that is example A, right? So that's how you can filter the data set. So now if you have any question that, why have I filtered this data set? Well, this is just like a precaution measure to, to make us prevent from making any mistakes downstream when we keep analyzing the data, right? So now what I'll do is I'll just run this particular command and then I'll view the data set. So when I say view example A, you can see that, a person's age is obviously greater than or equal to 18. So there's no child present in this particular data set. Now what I'm going to do is I'm going to perform t-test. So as I mentioned before, t-test is basically used to compare the means. So what I'm going to do is I'm going to use this predefined function in R to perform t-test, that is t.test, and then I'm going to perform the t-test between person age and sex, right? So the person's age is basically the response and the sex is basically the group. So this is basically a formula method to perform t-test in R, and data is basically your data frame, that is example A over here. So when I run this particular command, you can see an output that, we have data to be person age by sex and t is 1.9122. That is basically the t value that is calculated and the p value is 0.055593. So when I say t-test is basically used to calculate the p value, that is basically the confidence value. So this value basically tells us that, if the p value is less than 5%, that is 0.05, then the t-test between these two values, or you can say the alternative hypothesis between these two values, is getting rejected. But yes, if it is more than that, then you can consider that it is around 95% correct or apt to the sample estimates, right? So basically, with the t-test that I perform for person's age and sex, what I'm basically trying to find, is there any difference for the age of males versus females in this particular data set? So since the p-value is greater than 5%, you can see that, the mean in group of female is around 47 and mean in group of male is around 45. So yes, you can see that, there is a difference in age of males versus females in this particular data set. Now moving on to the next t-test, that is basically the t-test between body mass index and the diabetes status. Well, I'm performing this t-test to identify whether the body mass index differs between diabetics and the non-diabetics patients. So again, what I'm going to do is I'm going to choose this function t.t-test, and then I'm going to mention body mass index over diabetes status, and then I've mentioned the data frame, right? So I'll just run this particular command. Here you can see that the p-value is less than 5%. That means that obviously your hypothesis is going wrong, and then obviously the answer to this question is no. That means the body mass index does not differ between diabetics and non-diabetics patients. Moving on to the third t-test that I want to perform, that is liquor year versus relationship status. So basically, this t-test is trying to answer, do single or married people drink more alcohol or not? So again, I've just mentioned t.t-test, I've mentioned liquor year, relationship status, and the data frame name. And then I'll run this particular command, and you can see that p-value is again less than 5%. That means obviously there's no connection between both these values. So that's how, folks, you can understand how various columns differ over each other, or how various columns can be related with each other. Well, so that was all about t-test, guys. Now these were the various kind of skills, as I mentioned before, a data analyst should possess. Now moving on to the last skill, that is basically the machine learning. So as I said before, knowing machine learning is a bonus point. Now, obviously, how would you perform machine learning? That is basically you have to understand the algorithms and you have to build a model for it. So what I've done over here is I am going to just use the linear regression over here. So as you know, the linear models are basically the mathematical representations of the process that we think give rise to our data, right? The model basically seeks to explain the relationship between a variable of interest, that is basically our y variable, which is also the outcome response or the dependent variable, and one or more x predictors or the independent variables. So if we have y equal to b naught plus b1 x, then x is basically the independent variable and y is the dependent variable, and b naught is the intercept, and b1 is basically the coefficient that describes what one unit change in the x would do the outcome variable y, right? So that was a basic about linear regression, guys. Now building a linear model basically means that we propose a linear model and then estimate the coefficients and the variance of the error term. So as you can see, if you want to build a linear model in R, then you can just simply use the inbuilt function for linear regression, that is LM function, and then you have to mention the columns between which you want to calculate these values, right? So basically, I've decided to find the linear regression model for about person's weight upon person's height. And then over here in the data, I've mentioned my data frame, right? Now, after that, I'll just assign it to fit. So let me just run this particular command. Now, after that, we'll just find the summary of fit, right? So when we find the summary of fit, you can clearly see that, the p-value is less than 2.2 into 10 power minus 16. So that means the intercept term is not very useful most of the time. So this basically shows us what the value of weight would be when the height would be 0, right? So the value of weight would be around minus 19, which is impossible. So that could never happen. But if we observe the height coefficient, we can see that, it's really meaningful because each 1 unit increase in the height results in around 0.6 increase in the corresponding unit of the weight, right? Now, if you just want to visualize this particular model, what you can simply do is you just have to use the ggplot function, and then you have to mention the data set, that is example A over here, mention person height, person weight, GM point, and GM sport method to be LM, right? So if I just run this particular command, you can see that, we get a plot. So by default, you can see that, this is only going to show the prediction over the range of the data, which is very, very important to know. So for example, if you clearly see, the linear model tells us that, the weight would be around minus 19.8 kgs when the height is 0. Now, let me also tell you that, you can extend the predicted model's regression line past the lowest value of the data down to height 0. And also the bands of the confidence intervals basically tell us that the model is apparently confident within the ranges that is defined by the gray boundary. But if you just think about one thing over here, we would never see a height of 0, right? So basically, predicting past the range of the available training data is not a great idea, I would say, because there's no point in predicting the past range of data as the height would never go 0, right? So guys, that was about linear regression. So what we did in this particular demo was we started by importing a data set, and then we learned how to view the data set. After that, we went through a few simple commands, that is the head, tail, dimension, names, and glimpse, and then we understood how to perform descriptive statistics on a data set. So we understood how to use the unique function, the length function, the mean, median, and the range function. After that, I also told you how you can deal with the missing data, that is basic by using the na.rm parameter and also the is.na function. And finally, you can replace all the NA values with the 0, but only for those columns with the data type int. And then we performed exploratory data analysis, where we performed visualizations between various columns and we understood the relations between them. And then we finally performed t-test to understand and answer few questions and perform linear regression, that is basically a machine learning model, right? So I hope that you've understood this particular part of the session. So folks, that was all about data analytics.